Suppose you have a fuzzy image, and what you want to do is to recover the original as cleanly as possible. What that requires is that you reconstruct the original, or sometimes called the ground truth. The problem that arises is that it depends on the mechanism or the algorithm that you use to do the reconstruction. What happens with most algorithms is that they try to extract or make it as accurate as possible to the original and try to eliminate all the wrong things. However, what that can do is to generate biases that tends to get amplified when you are trying to do it in this way. So today I'm going to talk about how that arises in a particular problem and then generalize to it. The problem that gained a lot of reputation is what is known as the white Obama problem. With that intro, let me go directly to the matter at the heart of the problem. So you have a fuzzy image, you want to reconstruct the image, and your goal is what is called the ground truth. Here is the classic image alluded to in the intro of this talk. Most people around the world would look at this fuzzy image and would say, this looks kind of like Barack Obama. So what we want to do is to apply an algorithm to recover the image of him or as close to him as possible. So here is what the actual process did. The standard method, sometimes called the pulse method, produced this image out of the previous image that we saw. And there was heaps of criticism of that. To start with, this does not look like Obama at all. In fact, a lot of people argued that this resembles more like a white person. So essentially, Obama has been whitewashed. You know what I'm talking about, what the original image was. It looked like this, and that's clearly recognizable as Obama. But if you looked at the reconstructed one in the previous slide, it looks nothing like. Same program didn't just distort Obama's picture, it also did something strange with other pictures too. So most Indians, for example, will recognize the top blurry picture as a person, a Sikh person with a turban. And this is what the end result at the bottom is, what this kind of program produced. That you know, this is what the original image was that was made blurry, which appears at the bottom, and that's what the program was trying to reconstruct. It's not that the program always did bad things. Those were the two pathological examples that we picked. It did other things too. For example, the image on the left of the top there is the image that was presented to the program, and it regenerated the image of the man on the right, and it looks fairly close to the actual picture of that person. By looking at the Swiss cheese picture, it is rather difficult to reconstruct that one. And the second one at the bottom is even more striking. What the program was presented with was this bottom left-hand image, and it looks pretty black, but if you look close enough, you will see there are some dots in there, and it reconstructed the picture on the right, and it looks fairly close to the actual person. This is actually the problem that arising from all of this. Essentially, it boils down to this. we are trying to classify, in this case, image identification. Uh, what we want to do is to have a crisp answer, namely yes or no, or a picture between cat and dog, or if it's a person, black or white. For racial classification, the problem is compounded because it's never binary. All we have to do is recall that even though Barack Obama is considered black, he's actually half white, so he's 50% white. The reconstruction algorithm that we normally use are designed to maximize the accuracy of the program, of the image that it is going to generate. Now, in the process, it hits the actual thing so hard that it often increases the bias, and if there is a small bias, it gets amplified. Let's look at that from a Bayesian point. Let us assume that we have observed a noisy version of Y of an image X star that is either a dog or a cat. Assume cats are the minority, and let's assume specifically the probability of X star being a dog is 0.8. Further assume that the measurements that we are making are noisy and cannot definitely identify the species. So cat-like measurements are such that the probability of Y given the X star is a cat divided by the probability of Y given the X star being a dog is less than or equal to 2. So we are putting our finger on the balance and tipping the balance in favor of the dog. There are more dogs than there are cats. With that noisy input, we are trying to figure out what the probability that X star is a dog given Y. So this is a classic Bayes problem. And we split that up in two parts, multiplying by those two probabilities. Now, if you do that calculation, then you end up with the probability that our sample happens to be a dog becomes greater than 2/3. And what that means is that when you do this classification by a Bayesian method, you're actually tipping the balance further out. And that is what ends up happening. You essentially you give the model, you actually reward the model more in favor of the dog. Now, this white Obama problem is a pervasive problem. It does not apply just to the images, although we illustrated that with images. It also applies with equal force for large language models like ChatGPT and the Bing and the forthcoming Google's Bard. They all are large language models, and they all use loss functions that amplifies the error to get closer to the ground reality or the original text. So essentially, these models typically train on internet data. There are some other data, but the internet data dominates. What is the problem with that? Most of that is in English, which means that other language usage gets short shrift. If you are another major European language, because of the translations are relatively good, you sort of get a free pass. But if you take any of the Asian languages, especially the ones with their own alphabet, then you have a major problem. And secondly, because of the first problem that I mentioned, it is also written from a very, very Western worldview. And that is the second problem, which makes the whole white Obama problem worse. And this we will see playing out repeatedly as more and more access we have with the large language models that we are just beginning to have.